How attackers exploit system complexity. Modern systems are complex by design. They are composed of many layers, dependencies, and interactions. This complexity enables scale and flexibility, but it also creates opportunities for exploitation. In this video, we are going to look at how attackers exploit system complexity and why complexity itself is often the real vulnerability. Security failures rarely come from a single broken component. They emerge from interactions between components. Each part of a system may be secure in isolation. The failure appears when those parts interact in unexpected ways. Complexity hides these interactions. Attackers do not need to understand the entire system. They only need to understand how parts of it fail together. They look for gaps between responsibilities. What one component assumes another is enforcing. These assumptions often go unverified. Complex systems rely heavily on trust boundaries. Each boundary defines where responsibility changes. Authentication, authorization, data handling, and execution are often split across layers. When trust is delegated, enforcement becomes fragmented. Attackers exploit these fragments. Another feature of complexity is configuration. Modern systems are highly configurable. Flexibility allows systems to adapt, but it also increases the chance of misalignment. Defaults may be secure in one context and unsafe in another. Attackers look for configurations that were never meant to exist together. Complexity also creates cognitive overload. No single person fully understands the entire system. Teams specialize. Knowledge becomes distributed. This creates blind spots. Attackers benefit from these blind spots because no one notices issues that fall between domains. Change amplifies complexity. Systems evolve continuously. New features are added. Old assumptions remain. Security controls may lag behind architectural changes. Attackers exploit the delay between change and understanding. Complex systems also fail non-linearly. Small changes can have large effects. A minor permission change can expose sensitive paths. A small integration can create a new attack surface. Attackers search for these leverage points. Another advantage attackers have is patience. They observe, they test, they wait for changes. Complex systems produce constant noise. Subtle malicious behavior is easier to hide when systems are already noisy. Defenders often try to reduce risk by adding controls. Ironically, this can increase complexity. Each additional control introduces new interactions. If not carefully designed, controls can create new failure modes. Attackers adapt faster than complexity is reduced. Complexity also weakens accountability. When something fails, responsibility is unclear. Is it a configuration issue, a design flaw, or an operational error? This ambiguity slows response and learning. Attackers exploit slow learning. The key lesson is this: attackers do not defeat systems by breaking rules. They exploit the spaces where rules do not clearly apply. Complexity creates these spaces. The more complex a system becomes, the harder it is to reason about its behavior. This does not mean complexity should be avoided entirely. It means complexity must be acknowledged as a security factor. Systems that assume components will behave perfectly in all combinations are fragile. Security improves when systems are designed to fail predictably, when assumptions are made explicit, when interactions are understood, not just components. In the next video, we will look at why security failures often repeat and why organizations struggle to learn from past incidents.